San Francisco.
Yeah, 'cause I used to live in 8th and Geary down the Richmond.
Oh, okay, yeah, that
Went to
part.
San Jose for 2 years. First
okay.
2 years of college, I was a Spartan. Great
Ah,
place.
okay.
8th in San Fernando, right by the campus. Anyway, I'm sorry, I digress. Go ahead and switch the slide. I'm gonna bang right through my background so we get to stuff that matters. Just a little lesson. Go back one.
Sorry.
San Jose State, 1976, 1978. I'm old. I hated science all my life. Was fascinated by books though. I went to more schools and there are grades. We moved everywhere. Was not a military brat. Ended up going to San Jose State for religious studies philosophy. Thought I was going to be a minister. Ended up taking a botany course because I had to. I figured how hard can that be? They don't bleed, they don't run, they don't scream. It's got to be pretty easy. Fell in love with it. Transferred to Long Beach. Ended up getting a bachelor's in zoology. Dug up dinosaurs in Colorado to get my graduate work. Taught anatomy and physiology. Next. And I've done a ton in the industry. I've been in the industry for about 45 years. Kids blow through that.
You got it.
And what I'm going to talk about today is how we clean up toxins. And what we like to look at is, when we think of toxins, you guys have mercury here. I've worked with mercury at the Ostrom Sylvania plant in Danvers, Massachusetts. Worked with cadmium. You got cadmium here. I've worked with cadmium at the pigment facility in Nicoa down in Manchester, New Hampshire. Big exposure. You can talk about that one a little bit. Asbestos. I've done asbestos. PCBs, and I'll talk about that a little more in depth. We had a big PCB issue. Any locals? Any day students? Down in Claremont, at the Lowe's. That was my site. Years ago. Almost a love canal in Claremont, New Hampshire with PCBs. They're close.
That's close.
All of those things we consider as contaminants because they're a threat to you and me and to organisms that we look at with big eyes and make happy, Bambi and the deers and whatnot. But we look at it in some instances to microbes. For microbes, it's food. It's either food or something to breathe. And so I founded this company in 2008 with a group up in Canada. Our idea is we try to leverage what Mother Nature already does. Go ahead and hit the next switch. We try not to dig things up. We try not to have, we try to minimize our impact as much as we can. And what we do is we biostimulate the native microbial populations. I know Alan's going to ask you, what does Ken do? We biostimulate native microbial populations. And what's that mean? There are billions and billions of bugs in us. Like we were just joking earlier, there's a great talk, and I think Alan will give you the reference from a woman, Dr. Bonnie Bassler at Princeton. And she'll say to you, you all like to think of yourselves as human beings. Well, she looks at you as 99.9% microbial. And she's probably correct. We have these little human traits with us. These guys can eat and breathe contamination. Little one-cell organisms with one simple strand of DNA are able to assess their environment, share information, and ultimately eat contamination in the terms of, what do I mean, like gas, diesel. I always spell it wrong, I think. Diesel.
You see that okay?
Yeah.
You see all right? Okay.
And then,
there's other markers right here, Ken.
okay, CVOCs, chlorinated solvents. Go ahead and hit the next slide. And the way I do it is we inject stuff into the ground, and I'll get to that real quick with some pictures. This is not biostimulation. Traditionally, we dig it up. And I guess I'll go to that picture right away. You got a gas station. Some of you are driving now, and you got to go to the gas station and pay for your own gas. When you pull into that gas station, you got your car. Not that great of an artist. You got your car. You pull up, and there's that dispenser right here. And you take the hose and start putting 10, 12 gallons of gas into your car. Underneath that gas station, anywhere is from 12 to 20 feet below the ground surface, is an underground storage tank, a UST. In that underground storage tank is anywhere from 10 to 20,000 gallons of gas, diesel, whatever it is, kerosene, whatever you're purchasing. 18 feet, 16 feet below the ground, the ground all of a sudden gets real wet, or we'll call saturated. Can you see this marker any better than that one? And we use that little diamond, that little caret sign, to show where the ground is dry, where it becomes saturated. The ground's got pores, openings, holes, and through those holes runs water, just like a river above ground. Up here we got a stream running next door to here. It's a little more complicated, it's a lot deeper below us, but 20, 30, 40 feet, sometimes 100, 200 feet below ground are rivers. This gas tank occasionally ruptures, corrodes. There's piping that take it from here to here to here to here, and at each one of those there's junctions and valves and meters that can all points of failure. And if this happens, all of a sudden you get this big old plume of contamination in the groundwater. Historically, we come out, well, let's just dig it all out. We're gonna dig it all out. It's a lot of fun. This is a lot of fun. It's like playing in the sandbox, but you don't have to make noise anymore. You got these huge pieces of equipment. That's me running around. And this is the site in Indianapolis. That's downtown Indianapolis right there. This is like 50, 60 feet below ground surface. You dig it up, put it in a truck, haul it off to a landfill that may or may not be better, any better than this hole in the ground here. Because there's no liner, there's no protection. We're just taking it a problem from here because it presents a risk, and we're gonna put it over outskirts of town where right now it doesn't present a risk, but it may in the future. What we try to do in this groundwater are billions of bugs. There's an old guy, Carl Sagan, you may hear about someday. Carl Sagan would say billions and billions of light years or stars. There's billions of bacteria in the ground.
That's what you mean by bugs.
Bugs. That's
Bacteria,
what I mean by bugs.
microbes.
Single cell, unicellular guys that some have tails to swim, guys and gals, excuse me. Some have cilia that, when you're in original biology class and you looked into the microscope and you saw those guys swimming around in the pond water, those guys. We now know those guys are incredibly adaptive, incredibly intelligent, in that it takes us to adapt, to evolve decades. Because you had to grow, be able to have children, and those children had to move on so that we can evolve from one pressure to the next. These guys do it every other day, every other hour, some of them every minute. They evolve and adapt. Boom. So what we do, instead of digging it out the ground, see if is the next one not? Oh, what is? I inject an additive. We inject it into the ground. So you get this probe up here, this drill rig up here, and it pushes, just so happens to be red, that worked out good. It pushes this probe down, and then, spews out my additive formulation.
And these are just, these are microbes?
I'm not putting any microbes in the ground.
Wait, so what are these things?
Right now, the microbes are there. Mother Nature's figured this out for 4 billion years. She's been doing this for 4 billion years. But when the gas gets down here, or just even in normal conditions, 30, 40, 50 feet below the ground surface, the earth isn't as friendly as it is up here. There's not as many nutrients, there's not as much food, there might not be something to breathe as like there is up here. They're stressed.
So basically you're giving nutrients to microbes that dissolve or like eat up these, like the corroded gas and stuff.
Perfect, exactly. That's exactly what I did.
But the microbes are eating the
The
gas.
microbes are eating it.
Yeah,
What
so he's-
I'm doing, so at a gas station, if you specifically, the gas gets down here and takes away everything they could possibly breathe. It's actually respire, they don't have lungs, so I'm not supposed to say breathe, it's just blah, 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 technical guys. There's billions of them down here to breathe. There's this huge plume of diesel or gas, that's food. Pardon the expression, they're pissed right now, they're bummed. Cause you're at Thanksgiving dinner, you're starving, but mom won't let you in yet. Oh, no, the jello's not ready. You know, don't take a bite, we gotta wait for grandma or Uncle Jim. They're waiting for a chance to use this food that we call a contaminant. I inject my additive to give them something to breathe, or to give them food, depending on what the contaminant is, and I need to make them do. But we get them kick-started, and once they get kick-started, they secondarily eat. If you looked at this picture, if I'm a drone, and I go up, and if I were to look at this picture down on the surface,
Should I go to that picture?
just keep going through that.
Yeah.
The gas station's here. I'm looking down on the roof of the gas station now, all right? And under the ground is that gas tank. And here is your car and that dispenser. We're looking down on the roof of the building now, all right? And that plume goes like that. There's a lot of it here, not so much there, less there, and hardly any here. But there's that plume, and the way we figure this out is before I inject something, we gotta know where to put it. And so the consultants go out, the designers, the architects, if you will go out, and with a similar piece of rig, similar piece of equipment, push a hole down into the ground and put a solid piece of PVC, regular old PVC, you see at Home Depot, or excuse me, Lowe's, thank you. But at the bottom of it, where the groundwater is, it's screened. That allows water to go through it. Does that make any sense so far, guys? And we do it a lot.
So that's an aerial map
These are
right there.
all the places we drilled. This is just one gas station.
Go ahead, Billy.
So with the microbes that are in the soil, are there certain ones that that dissolve certain chemicals, or
Yep.
is it like that you select? Can you select which ones to I don't know, activate by the nutrients that you put in, or is it like you feed everything?
We used to, traditionally, we used to only think that, first off, yes. You could type really well. You could do math really well. See, that was sexist right there. You're a physicist. You all have certain tasks that you can do. But we need a typist right now. And so we put in an additive, and now all of a sudden you got 10 more typists, and you got 10 more of everybody else, beneficial and non-beneficial. But we got the 10 more people that we needed. So we're getting a little bit better performance.
So you can't selectively choose more.
And sometimes in the lab, we'll take her and say, all right, I'm gonna select you to do this. But what we now, and grow more of just typists. And then you go out in the field, and we used to think that these selected bugs were smarter and could adapt to the environment better. They'd survive better than the native bugs. So we'd inject them in with the additive, because, oh gosh, now we're putting in more of those bugs. Well, we now know what really happens in the real world. They get killed.
The selected
The
ones.
selected ones, because they're not, it's like,
You're too selective. You're too specialized.
selected. It's like having a monoculture of forest, and all of a sudden the pine beetle comes in. There's no defense. It's like, if anybody knows Los Angeles, it's like me putting on a suit and tie and having money sticking out of my pocket and being putting that down in Watts, or South Central Compton. I ain't gonna fare well. What we now know is if you make the right environment, these bugs she can go and say, hey fellas, this is how you do it. She can teach us, we can recruit each other, so now all of us eat that material. The reason they could do that is, remember I said they could evolve in days, minutes, hours? It's because they can evolve days, minutes, hours.
So
They were dormant right here. There was nothing for them to eat or breathe. There was nothing going on here. All of a sudden, my nutrients come in, and now the Thanksgiving door opens. Then you can rush in and eat. And maybe somebody doesn't know how to hold a fork right. Well, you're gonna show them how to use a fork right. 1 minute.
no.
Oh, okay.
I wanted to just interject. one of the things that you were saying to me that I thought was really cool that we forget about with bacteria is they're one of the oldest living organisms on the planet. They've been around for about 4 billion years, 3.5 billion years. So they have a lot of DNA, a lot of information. So they're very adaptable. They have genetics already there. And one of the things we've learned about bacteria is they communicate through quorum sensing. So as soon as, like if we say we're all bacteria in here, and Haley is our typist, and that's the skill that's needed to get food in this environment, she could then have a quorum and share all that genetic information, and we all become typists. Is that right? Is that the right way?
This way.
And that's what happens with bacteria. They can all change.
Haley has a toxin. She's a single cell bacteria with a toxin.
Sorry, Haley.
And she gets into one of us. We're huge. She's this little tiny little single cell bacteria. And she spews out her toxin, and you're still doing your thing. You don't care. But if Haley can go around and let the population's densities grow and get to a threshold, and as they're growing, she's assessing who else is around here and is able to send out a message through quorum sensing and signaling, QSS. It's almost like hormonal signaling that our cells do.
Right.
It's a whole different process, but it's similar to that. She can start sharing her DNA, and she's going to start showing each one of us how to produce that toxin. And say, wait. The population grows, reaches a certain threshold density. And if the right nutrients and if the right triggers are there, Haley goes, now! And we all spew our toxin all at once. What do you got? You got 103-degree fever. And it's so effective that, like with a hip transplant, it's an anaerobic world. It's warm, nutrient-rich. It's called a biofilm. What happens is these guys make a biofilm.
Shall I go to that slide, Kent?
Yeah. And a biofilm, when I was a kid, you'd cut yourself and it'd start getting pussy, red and dirty. And Ma used to put mercurochrome, iodide, all over it. And that was to kill the bad bacteria. Well, we found out iodide had thyroid cancer issues, so we stopped using that. And the next thing, way before you guys were around, we'd pour peroxide all over our hands if you got a cut and pus. And that peroxide bubbled and fizzed because it had oxygen. It killed the biofilm. What happens in biofilm, in an anaerobic world, a noxic world, no oxygen, in a no oxygen world, they could create in this pus, they change their characteristics so that they can better share their DNA. And so you have a hip replacement. They get this biofilm going, an infection, and it's getting bad. Oh my God, I got an infection. You're taking antibiotics. They can evolve so fast now. They outpace our antibiotics.
The microbes?
The microbes. Because what happens, should I get into it real quick? Should I get into that? No? Okay. What happens is when I'm a swimming bacteria, I have certain characteristics and certain capabilities. If I stop swimming, join the team and make a biofilm, my capabilities increase 1,000-fold.
So how do you leverage biofilms for cleaning up?
So what I do is in the medical world, and I stumbled on this through that Dr. Bonnie Bassler, he'll give you the reference. Yeah. I said, wait a minute. Why not do that in the ground? Why not take a wastewater treatment plant? Things we knew above ground, why aren't we applying this to the in-ground? Down here, it's nutrient poor. There's no nutrients. But there's a ton of food coming along the way because we irresponsibly put this tank here and made a contamination problem. Well, I leverage that through Mother Nature. If I can help her create this biofilm, there will be a few dormant bugs who have DNA capability to use that organic food as energy. So that within this biofilm, in days, weeks, months, they evolve to use that as their collective primary source of energy. They abandon their individualness, they abandon what they wanted to do, after school, so that collectively, as a consortium, they act together to benefit everybody. Even at the expense, some of them even go ahead and die so that they can spew back all the nutrients we gave them. It's called endogenous decay. That's what makes it, that's what makes it recycle. This will go for years after one process. Now, in terms of money, that's great if you're an owner of a contaminated site and you have time and you don't want to spend the money. Nobody wants to spend a lot of money in my industry. Very, very few people wake up and say, you can go on, keep going.
To what? Which slide?
I have no idea. I don't even know what's next. That
So
was
you're at the end of the slide.
that was a biofilm. That blob,
Let me go back.
that's the biofilm. And once they make this biofilm, the majority of all the bugs go in, it's like a house, it's like a protective housing. They send scouts out after a while to start looking. They've adapted now to this new energy source, this contamination. And they say, wow, this stuff's pretty cool. And so they start sending out scouts. Are there any more of is there any more of this condition out there? And so they typically think when I inject, we're gonna get like 20, 30 foot of influence. Like if I injected right here, it's gonna go maybe to Allen. We're seeing at a couple sites, 105 feet down gradient, like 5 years later, we're getting influence with contaminant degradation, where we weren't
So
even close to.
The film finds it.
It grows because of the current, it breaks off and latches onto a happy world, or these guys go swimming around
Forming
and
a
go,
film.
holy smokes, this is just like where I left, this is awesome, let's do it again, and they start making a whole new biofilm.
Okay. Billy.
There's more biofilm than anything else on the planet in terms of organic life. I'm sorry, go ahead.
When you inject the nutrients, do you have to do this like is it like feeding like a dog? You have to do it often, or you just do it once and then like the whole community?
Depending on the contaminant. Now, if you've all gone with mom and dad, or you guys have gone yourselves, like a prom night or something, you had to go to the dry cleaner. And you had to get your clothes dry cleaned and pressed. That's a chemical, have you ever done that?
Yes.
Yeah. That's right.
Go on.
It's a chemical process. Instead of throwing it into the washing machine, washing it, agitation, dry cleaning is a chemical process. And it uses the solvent PCE. I'll just do this real fast. PCE has a chlorine atom, it's got an electron on it. Bugs can breathe that. Just like us, when you breathe O2, right? I don't know, quick category. It's O2 because of the electrons. All right? When you inhale that, you use one electron and then exhale it as CO2, right? Bugs can do the exact same thing. PCE has 4 chlorine atoms. I know I'm going way out of control now, but it has 4 chlorine atoms. There are bugs that we enhance will breathe this in, use that chlorine, replace it with hydrogen, and so it goes PCE, and then it goes to TC, it goes all the way down, you'll have
It breaks it down.
chloride, and it breaks down. So your question is, at this site, we can inject once. I have a site in Lebanon, New Hampshire, it's been 21 years now. It broke everything down in 7, but conditions are such, it's like we injected yesterday at that site. 21, so sustainability of the site conditions has lasted over 2 decades. At a petroleum site, you have to inject 2 or 3 times, and there's various reasons for that. But you can get years to decades of life, but yes, you have to inject more often than once. Any other questions?
Wait,
Tell
do
us
you
about,
I'm sorry.
go ahead, do it, Elena's, and get us to money.
Do you primarily work at like gas stations?
I think that's one of the, or we passed that one.
I can
Gas
catch with that.
station, no, I don't matter. Gas stations, dry cleaners, there are tons of places, you know, take a picture, it'll clear everything up when you look at that picture later on today, this here. There's all kinds of places that have these, you have them here.
Oh, okay.
A lot of homes have them in their basement, you know, our home heating oil is oil, et cetera, et cetera. So, oil manufacturing facilities, what we call brownfield properties. Brownfields are oil manufacturing facilities, like when you drive through Manchester and you see all those red brick mill buildings. Back in the 1850s, Manchester was the #1 textile place in the planet. That place was a hot, and you see those pier footings in the river? Those used to be the pedestrian walk bridges. The workers were on the west side of the river and all the manufacturing was on the left. Well, those got dilapidated, broke down, run down. Well, this is in Franklin, and it's in the process of getting fixed up now. It's come a long ways. These old buildings have potential, but they need to get cleaned up. So that's a brownfields. Gas stations, there's 121,000 documented abandoned gas stations that need cleaning. There's 35,000 abandoned dry cleanings. This doesn't count the ones that are operating. We've done, my generation and the military in the World War II generation, we've done a really, really good job of creating a long-term industry for you guys in environmental remediation, unfortunately. We need your help. PFAS, one of the really cool things that we think with biofilm, 1,4-dioxane, you guys talked about in Love Canal. We used to think about 5 years ago, bugs couldn't touch it. Dr. Mahendra, I'm working with Dr. Mahendra at UCLA, she's proven in a biofilm they can eat it very well. They can use it very well.
PFAS as well?
We believe PFAS is just another organic molecule. It's really, the hard thing is, how easy can you get the electron off?
Right.
That's the trick. Go ahead.
I'm just confused, what happens if you don't, like, feed them? Like, the bugs? Like,
They don't perform?
Like, what?
I don't get hired again at that. I lose the job.
No, like,
Good.
what are they doing? Like,
Well,
why
there's
are they
other-
feeding them? I don't understand.
You mean, are there other ways of going at this? What
No,
if
just
this
like-
didn't work?
Just like, what are they doing? Like, I don't.
They're
What are the
breaking,
bugs actually
Yeah,
doing?
like,
Well, for instance, the bugs at a dry cleaner site, when you breathe in, you're using oxygen, you can't see it. They're doing the same thing down here in the ground, just these little microscopic guys, and they're just living. And it's, through various transport mechanisms, they use that electron so they can have more of themselves.
they basically
they-
digest the
And
chemical
they use it
over
as an
time.
energy.
They
Mother Nature
digest it.
uses everything as energy. She could care less about us. And one of the beauties of microbes is we make these things that are looked at as a contaminant. In time, Mother Nature's gonna, if there's energy involved, if there's an electron, at some point, Mother Nature's gonna figure it out. It might not be in time for us, but she's gonna figure it out. Go ahead, Alan.
Keep asking questions, this is great. Go ahead, Stephanie.
Is it like good that we're doing this, or like
Yeah.
for our environment? Because like they're adapting so quick. Like, is it gonna affect like us and like our, I don't know, you know what I mean?
These guys, okay, so,
Like if bacteria like gets on us, like are they gonna adapt? Like does that make them adapt?
we're go through a bunch of slides.
To what,
They're
okay,
not all bad.
Yeah.
where do you want me to go?
You, like I said, you are 99+% bacteria. The reason you don't wake up like a blender, a homogenized blender of kidney, liver, lung, goo, is because you have bacteria creating biofilm around cells, telling them what to do, stay there and be a liver. I know it's crazy, it's really, but it's so cool. And so what we're doing, so what happens if it doesn't work? What happens if it didn't work?
Yeah.
The bugs stay dormant. They don't do anything. And then I put some stuff in the ground that, luckily, all my additives are organic. Whatever I put in the ground doesn't harm the ground. It just didn't help the bugs. So it didn't accomplish what we wanted it to do. but I'm not creating other problems.
Why do we need this? Like, why do we need to do this?
Well, you have this.
Do the
so this-
cost benefit analysis, Kent. Show them the cost difference. Why?
Why do we need to do this, or why do we need to do this? Why do I need to address this?
Yeah.
Alright, so when you're at the gas station, and you're putting gas in that tank, what do you smell this, or you're at home filling up the lawnmower, you smell the gas. That's a volatile gas. Breathing those fumes cause cancer.
Benzene.
Benzene, it causes your genes to go, and you and/or you have every egg your kids will ever have.
Right.
You have every egg your kids will ever have.